Hello everyone, I am Christo from the Department of Chemistry. In this video, we discuss about nature of carbon bonds. Now we discuss about covalent bonding. Carbon is known for its ability to form strong covalent bonds. Covalent bonds involve the sharing of electron between the atom. Carbon has 4 valence electrons, allowing it to share electron with other atom to achieve a stable electron configuration. Trivalency. Carbon typically form 4 covalent bonds, making it trivalent. These allow carbon to create diverse and complex molecule structure. Hybridization. Carbon atoms often undergo hybridization to form stronger and more stable bonds. Common hybridization states include sp3 tetrahedral geometry, sp2 trigonal planar, sp linear. Isomerization. Carbon bonds exhibit isomerization where include with the same molecular formula have different structures. Structural isomer have different arrangement of atom while geometric isomer have different spatial arrangements. Electronegativity. Carbon has a moderate electronegativity allowing to it to form both polar and nonpolar covalent bonds. Carbon-carbon bonds are typically nonpolar when the bonds are identical, while bonds with more electronegative atom can be polar. Pi bond and sigma bond. In addition to sigma bonds formed by head-on overlap of atomic orbital can be form pi bonds. Pi bonds results from the side-to-side overlap of p orbital and are common in double and triple bonds. Conjugation. Conjugated systems involve alternative single and double bonds in a molecule. This arrangement can lead to enhanced stability and unique electric properties. Resonance. Delocalized electrons contribute to the stability and unique property of the molecule. Resonance structures are multiple valid representations of a molecule. Hydrogen bonding. While carbon-carbon bonds are not capable of hydrogen bonding, carbon-containing compound had participate in hydrogen bonding through hydrogen bonding bonded to electronegative atom like oxygen or nitrogen. Stereochemistry. Carbon compound can exhibit stereochemistry where the spatial arrangement of atom affect the molecule properties. Enantiomer and diastereomer are common in stereoisomerism. Organic functional group. The diversity of carbon compound arises from the presence of functional group. Functional group are specific arrangement of atom that conform characterization chemical properties to a molecules.